NOVAS. Energy Services. Authentic Energy.
At the present time, recoverability of raw material reserves is one of the basic tasks faced by the producing companies in the world. All known methods, i.e., primary, secondary, and tertiary, allow recovery of 25 to 50% of the hydrocarbon materials from the underground resources. Thus, more than 50% of the hydrocarbons are left behind in the earth. At this time, the world's scientific efforts are aimed at finding new methods to increase recoverability from the oil strata, which would allow the world's proven reserves to be extended and value of oil recoverability to be enhanced up to 50%, with the prospect of further growth. Here we should highlight the basic geological features and physical properties inherent to all wells in reservoir. The geological structure of the rocks forming the reservoirs is not homogeneous, the remaining oil being concentrated in zones of poor drainage, the so-called unrecovered oil. According to its acoustic properties, a reservoir is an array of vibrating systems. By now, it has been ascertained that a periodic pulse influence on the layer system boundary can result in a parametric resonance in it. Well building is accompanied by formation of a drainage area, the condition of which has a substantial impact on the well productivity, both at the development stage and within the entire period of the well's operation. The basic factors determining the permeability-mobility index in the drainage area, which are common for all wells, are the following: colmatation, clogging of the well drainage area by solid particles present in the liquids used for opening the well and its subsequent completion; clogging by the drilling mud; clogging by salts and paraffinaceous asphaltic resinous components. So it is evident that a device is needed which would be able to clear the drainage area of colmatant and to increase the permeability of the strata at the same time. What is needed is a generator making it possible to reach outstanding results in the sphere of oil production stimulation, stratum recovery enhancement, and acceleration of putting new wells into production. Let's have a look at that structure. The plasma streamer generator housing is composed of a metal cylinder of 2,060 millimeters and outside diameter of 102 millimeters. A block of energy storage capacitors, a high-tension block, a high-voltage transformer, a control card, electronic emitters, and a device for plasma channel formation. The operating parameters are: supply voltage 220 volts at 50 Hz, supply power 500 watt, power capacity 1.5 kilojoules. The generator is capable of withstanding media pressure of up to 400 atmosphere and temperature of 100 to 120 degrees centigrade. Control is performed via KG3 logging cable with an NK60 head using a control module. The plasma streamer allows the following effects to be achieved: removal of colmatant from the production injection well drainage areas, influence on the production strata for oil recovery, acceleration of the well development period, and putting the new wells into production mode sooner. The treatment starts with the lowering in the hole, cleared of the pump and compressor equipment, of an implosive device with a plasma streamer geophysical complex system, which performs the following: fluid sampling and determination of hydrostatical parameters, i.e., pressure, temperature, flowing level of liquid, determination of the working perforation intervals, Then the plasma streamer generator is lowered and positioned at a prescribed interval point. The control module is used to generate a series of plasma pulses, which take some milliseconds to eliminate the clogging, collimation, of the drainage area due to a dramatic compression shock and temperature rise in the plasma channel. The collimating matters get pressed into the stratum, and when the plasma cools down, they are forced into the well by the strata pressure. The shock wave forms a broadband acoustic field, which transforms into primary and transversal waves in the liquid media of the stratum. The latter ones fade out rather slowly, and because of that, their amplitudes increase with subsequent pulses resulting in resonance events. The following effects can be observed in that case. Multiple increase of liquid aggregation. Due to appearance of low flotation, the oil drops are forced up to the surface. Due to action of the elastic waves, new fissures appear in the rocks of the stratum. Permeability enhances, the porous space changes, and oil displaces water. The elastic waves reach the neighboring wells, enhancing the filtering properties of the stratum. On completion of the treatment, the generator is hoisted and taken from the well. The plasma streamer geophysical complex is used for cleaning the well of colmatant, after which the hydrostatical parameters are determined anew. The whole operation takes less than 24 hours, after which the well is put right into operation. The following diagrams can be used for assessing the dynamic values of the treatment with the aid of the plasma streamer equipment. This injection well in the Vakskaya field was inactive due to lack of intake capacity. Thanks to the treatment done with the aid of the plasma streamer, the injection capacity of the well increased to 30 days after the treatment, amounting to 194 cubic meters per day at an injection pressure of 145 atmospheres. After 9 months from the treatment, the injection capacity of the well amounted to 189 cubic meters per day at an injection pressure of 140 atmospheres. No additional work was done during treatment of the wells using the plasma streamer equipment. Treatment with the aid of the plasma streamer equipment at a Mudavlinskaya field was well conducted for the purpose of increasing the injection capacity of a certain producing layer. Before the treatment, the injection capacity of the producing layer was 29.2 cubic meters, or 8% of the total injection capacity of the well. After treatment, the injection capacity of the treated layer increased up to 150.4 cubic meters, which amounted to a 32% increase in the total injection capacity of the well. No additional work was done during the treatment of the wells with the aid of the plasma streamer equipment. To the same level of advantage, the plasma streamer equipment was applied at the production wells. This well of Zimnia field was treated at the development stage. The stratum featured a low permeability of less than 4 millidarcy, which meant that well development using the traditional methods would be expensive and time-consuming. After treatment of the well using plasma streamer, 2 days after introduction of the well into operation, the operating parameters were as follows: fluid flow rate 25.2 cubic meters per day, oil flow rate 20.8 tons per day at a water cut of 5.2%. No additional work was done during treatment of the wells using the plasma streamer equipment. A producing well of the Tylakovskoye field was treated using the plasma streamer for the purpose of oil flow rate increase. After the treatment, the oil flow rate increased from 7 to 22 tons per day, and the water cut dropped from 18 to 7%. No additional work was done during treatment of the wells using plasma streamer equipment.